In this lesson, we're going to look at verifying inverse function ordered pairs. And as we study this topic, let's look at these two graphs. Now, I want you to notice that my function f of x is this one right here. So that's this one. So I'll trace over it just to show you. So here's my function f of x right here. And you may not see the color, but that's a orange color that I'm tracing over with. So there's the function f of x. Now, remember, we talked about f of x, we talked about one-to-one functions. So I want you to notice that this function f of x that I've drawn here is a one-to-one function. So it passes the horizontal line test. All right, so we talked about the horizontal line test. So that's a one-to-one function. So since it's a one-to-one function, it's going to have an inverse. And so remember, if a function and its inverse are graphed on the same coordinate plane, it's symmetrical about the line y equals x. So here's the line y equals x, and notice that this graph here, and I'll go ahead and use a blue color just to show you, this graph here that I'm drawing in blue is the inverse of the orange graph. All right, so those two graphs are symmetrical about the line y equals x. So inverse functions are symmetrical about the line y equals x. And so if you look at let's say these 2 points here, right here, that I'm looking at right here, and I'm going to go ahead and use a pencil just to show you. But if you connect those 2 points right here, then that segment that I just drew right here is perpendicular to the line y equals x. All right, and the same thing here. So if I go here and connect those 2 points here, the same thing. So these two, this segment here that I just drew and the line y equals x are perpendicular. All right, so if it's drawn correctly, it's always going to look like that. But anyway, so there's the line, there's the graph of f of x, so there's my function, and then this is its inverse. Now, here's what I want you to notice. All right, now, so you got to listen carefully to this. So we know that f of x is a one-to-one function, so it has an inverse, and here's its inverse. And we know that that inverses, if you graph them, are symmetrical by the line y equals x. All right, so listen to what I'm about to say. So suppose I ask you find f of 0. Find f of 0. So remember what that means. F of 0 means when x is 0, what's my y value? So but remember, you got to use your function f of x. So here's my function f of x. Here's where x is 0. Here's the point. What's my y value? My y value is -1, right? Okay. All right. Now suppose I asked you, and I'm going to leave some space here. Suppose I ask you find f of, let's say, -1. So f of -1. Well, I go to my function f, which is this graph here, and when x is -1, what's my y value? Well, my value is -3, right? Okay. Now, remember, that's my function f of x. Now, what if I asked you, so I'm going to go now to my inverse function. What if I asked you this? What is f inverse of -1? All right, so remember, I'm asking when x is -1, what is the y value on that inverse? Okay, so when x is -1, which is here, what is my y value? Well, my y value is 0, right? And then over here, if I asked you what is f inverse of -3, what is f inverse of -3? Then that's asking when x is -3, what's my y value on the inverse? So here's my inverse. So when x is -3, here's where x is -3. Here's my point. What's the y value? The y value is -1. All right, now here's the connection I want you to make. So remember, my function f of x is a one-to-one function, so it has an inverse. So if you're told that f of 0 is -1, then on the graph of the inverse, all right, so let me write it down. If f of 0 is -1, now you have to assume that f, or you have to know or assume that f of x is a one-to-one function, and it is. You can tell it's a one-to-one function. It passes the horizontal line test. So if f of x is a one-to-one function, all right, and if f of 0 equals -1, then what that also means is this. On the inverse, f inverse of -1, so f inverse of -1 has to equal 0. All right, so that's what that means. So f inverse of -1 has to equal 0. Same thing with this one. If f of -1 is equal to -3, then on the inverse, what that means is that f inverse of -3 would have to equal -1. All right, so when so on the graph of f of x, if x is 0, my y value is -1. On the graph of the inverse, if x is -1, which you can see, here's the inverse, if x is -1, my y value is 0. On the graph of f of x, if x is -1, my y value is -3, and you see that. Here's the graph of f of x. Here's -1. Here's my point. Y is -3. On the inverse, it's just remember, it's just interchange. So if x is -3, then this is going to be my y value on the inverse graph, on the inverse. All right. So now we can say this. Now listen carefully to this. With all of this that we just discussed, we can now say this. All right, if f of a is equal to b, if f of a is equal to b, and if f is a one-to-one function, a one-to-one function, which means it has an inverse, okay? Has an inverse function. Then on the inverse, what that means then, so remember, on my function f of x, if x is a, my y value is b. So that means on the inverse, this would be your x and this would be your y. So then that means f inverse of b would have to equal a. So my inverse, when x is b, my y value is a. Okay? All right. So let's look at some examples. All right, examples. All right, so let's suppose you're told this. Suppose f is a one-to-one function. All right, so you have to be told it's a one-to-one function. So if f is a one-to-one function with the following values, then what else must be true? What else must be true? Okay? All right. So if f is a one-to-one function with the following values, you can see what I mean in a little while, then what else must be true? Okay, so here's what I mean. All right, so let's call this example number 1. And this will be the A part. So if f of 6 equals -2, then what are you going to say? So if f of 6 equals -2, say something about the inverse. Then that means that the inverse of -2 has to equal what? 6. That's what I want you to say. The inverse of -2 has to equal 6. All right. So if you graph the inverse, when x is -2, my y value is 6 on the inverse. On my function f of x, if x is 6, my y value is -2. On the inverse, it's just interchanged. All right. All right, B. All right, so here's B. So in B, if f of, let's say, -3 is equal to 7, then what else can you say? What else must be true? So if on my function f, or on the graph of f of x, when x is -3, my y value is 7, then what must be true about on the graph of f inverse? And what that means is that f inverse of 7 must equal -3. All right, so that's what that means. All right, number 2. All right, oh, well, let's keep on going. So let's call this C. So C, so if f of 3 is equal to 5, then what must be true? And that means f inverse of 5 must equal what? 3. F inverse of 5, oops, sorry, let me rewrite this over. F inverse of 5 must equal 3. Now remember, when we talk about inverses, the notation, always make sure that that inverse symbol for inverse is -1, that it's written as a superscript, okay? So it's written as looks like an exponent. So f of -1, although it's not, all right? So we've talked about this before in one of our lessons. Don't confuse 2 to the -1 versus f inverse, all right? Those are two different things. These -1s that you see here mean totally different things. This right here, 2 to the -1 power, means 1/2, okay? That's not what this means. So don't say this is 1 over f. That's not true, okay? So this means f inverse. This means 2 to the -1 power. So remember the words I'm using. 2 to the -1, f inverse, okay? 2 to the -1 power. And this right here means f inverse. Does not mean f to the -1 power. All right. So I'm just making sure you understand that. Okay. All right, so let's look at another example. All right, so number 2, it says consider the function g, which is a one-to-one function, with the following given values, or with given values. So you're told g of 8 is -3, and you're also told g of -7 is a -5. All right, and then they want to know for part A, you want to find what would be g inverse of -5. All right, and so you put the answer in the blank. And then part B, they want to know what would be g inverse of -3. All right, so it's very easy to determine just by using this. So if you're told that g of 8 equals -3, then that means on the inverse, g inverse of -3 has to equal 8, right? So we get this from that statement. And then from this statement, we get this. We get g inverse of -5 has to equal -7. And so now I know the answer. So g inverse of -5, that's this one. What does that equal? -7. Over here, g inverse of -3, that's this one here. What does that equal? That equals 8. All right. Now also make sure you understand that what that means is that if you were to graph g of x and its inverse, that on the graph of g of x, when x is 8, my y value is -3. When x is -7, my y value is -5. On the inverse, when x is -5, this is my y value. And when x is -3, that's my y value on the graph of the inverse. All right. So that is all I wanted to do in terms of this topic on verifying inverse function ordered pairs.